free charge and true charge on the plates of the capacitor. Now we will discuss this one. What is the meaning of free charge, what is the meaning of true charge, that we will do, and what is the relation between these two types of charges. Parallel plate capacitor. This we will discuss. This is now plate P1. This is now another plate. P2. This is now P1. This is now P2. And these two plates are connected to the source of voltage P. Then this will get the positive charge and this will get the negative charge, like this. So this charge is Q. This is now plus Q. This is now your minus Q. Let A equal to area of each plate Now there is the electric field like this. Electric field. This is now electric field E. E naught. Electric field E naught. When plates P1 and P2 are connected to a source of voltage V, the plates get charged. Due to free electrons in the plates. So what happens that when this source is connected to these plates P1 and P2, this plate is getting positive charge, this plate is getting negative charge because of this negative plate, and this is due to the free electrons in these plates, because plates are made of some metal. So because of them we are having the electric field E. So the electric field this charge on the plates is called free charge. So क्यों फ्री इलेक्ट्रॉन्स के द्वारा होता है इसलिए हम इसको फ्री चार्ज कहते हैं. तो हम मान लेते हैं let Q naught is equal to free charge. Free charge. So now what is there? That the capacitance is equal to, हम इसको C नॉट मान लेते हैं. So चार्ज कितना हो जाएगा? Therefore Q naught equal to C naught into V. V the voltage of this source. So this is not so much. And electric field कितना होगा? The electric field E naught equal to this sigma naught upon epsilon naught. Where sigma naught? This is equal to Q naught upon A epsilon naught. This is equal to E naught. So this sigma naught equal to Q naught upon A. Surface charge density. Let a dielectric slab of dielectric constant epsilon r is inserted between the plates P1 and P2. Now let us see then what will happen. These are the plates This is now P1. This is now plate P2. This is now P1. This is now P2. This is now the source. This is now slab. And this slab is this we take somewhat like this. This is now plate P2. Now this will get, this is charged, getting more charge. And this will get negative charge here. This is now positive charge, like this. This is now slab. This is now dielectric slab. So now what is happening? that when this dielectric slab is placed between these two plates, then the dielectric gets polarized. So on this surface we will have the negative charge, and on this surface we will have the positive charge. Now what is there, that when this dielectric is placed, the capacitance of this capacitor increases. So this is now charge, suppose Q, and this is now charge minus Q. So when this capacitance increases, then more charge is taken from the source of voltage V by the plates P1 and P2. So charge on the plates increases. Now this charge stored on the plates P1 and P2 is called the true charge. Due to insertion of dielectric slab, the dielectric gets polarized as shown in figure. As shown in figure. So the capacitance of capacitor will increase, and charge will be taken from source of voltage V by the plate. Plates P1 and P2. Thus the charge on the plates increases. Charge on the plate increases, and this charge is more than the free charge. It is called true charge. So now let Q equal to Q charge, true charge on the plates, on the plates. So now capacitance, the charge Q will be how much? Q equal to C into V. The voltage will remain the same because this source is in contact with these plates P1 and P2. So this is equal to this is not so much. C is equal to so now this Q is equal to epsilon R into Q naught. For dielectric, epsilon R is greater than 1. So this Q is greater than Q naught. Thus the charge on the plates increases. So charge on the plates is more than the initial value after the insertion of the dielectric slab. So this charge, this Q is called the true charge, and before the insertion of this dielectric, the charge collected by the plates is called the free charge. It means that the true charge is more than the free charge. अब इस चार्ज में कितनी बढ़ोतरी हुई, कितना इसने चार्ज लिया? Additional amount of charge taken from source of voltage B. Now this Q delta Q is equal to Q minus Q naught. So this is what? This is now your epsilon R into Q naught minus Q naught. So this is equal to epsilon R minus 1 into Q naught. So this is equal to what? Epsilon R. This is equal to delta Q. It means that so much charge has been taken from the source by the plates. And you can see clearly from here that if there is the air, then epsilon R equal to 1. So this delta Q is equal to 0 and this Q is equal to Q naught. For air, epsilon R equal to 1. Then this delta Q is equal to 0 and this Q is equal to Q naught. So when there is the air, then there is no change in the capacitance, so no charge is taken from the source. So thus when the source is in contact with the plates and the dielectric slab is inserted, then the charge on the plates increases, and also the electric field between them decreases, or the voltage also decreases. So now new electric field will be how much? This E is equal to sigma upon epsilon naught epsilon r, or this is equal to Q upon A epsilon naught epsilon r. Before this one I write down here this Q naught, but now I am writing this Q. So now you can see that this electric field is equal to so much, and this E is equal to what? This Q upon A epsilon naught, this is now E naught, this is now E naught upon epsilon r. So this electric field also decreases. Now we can have that this E is less than E naught. So electric field decreases, that means the potential difference also decreases. So this is what that we are having this electric field, and that the charge on the plates when the dielectric slab is placed between the plates of the capacitor. So this is the difference between the free charge and the true charge, and always remember that true charge is always more than the free charge on the plates. So thank you very much.